All right, so we talked about recycle. Something that's a little bit different than recycle, but same principle, is called bypass. And bypass is a procedure in which a fraction of the feed of the process is diverted around the unit and combined with the output streams of the units. So let's draw that because we don't actually have a figure here. So if we draw a little box, and this is our process unit, we have a feed coming in of some kind, doesn't matter what, and we have some kind of a product. And maybe we don't want all of this feed going in. Well, if we don't want all of this feed going in and we want it to go around the unit, we can have a split point, like we've talked about, and we can effectively bypass. So, kind of like a recycle, but in the opposite direction, and that's called bypass. So, why would we maybe need to bypass a unit? Well, maybe a specific chemical that's in this feed stream will hinder the chemical reaction that's going to happen in this process unit. If that's the case, we might need to bypass some of that chemical. We might also want to reduce the mass flow or the volumetric flow through the unit. So maybe this is coming in real fast with a ton of mass, right? And maybe this unit can't handle that. It's not designed for that. So maybe we need to bypass part of that stream. The other thing that we might need to do is keep a consistent concentration of a substance in the input. So if we always want this input to be the same, but this is very variable, we can have a splitting point where we make sure that this concentration stays the same and the bypass takes care of the rest of concentration. So that's it in terms of bypass. It's a relatively simple process and idea here. We're not going to go we're not going to go over a specific example of bypass, but you would treat it very similar to all the other problems we've been doing with recycle because you have a mixing point here and a splitting point here. So it's very similar procedures to a recycle.